Hello students, the class will begin shortly. Okay, if anybody can see this live stream, could you indicate so in the chat, please? Okay, good evening, Samir, Vanessa. Great. All right, so this evening we'll be doing geometry and trigonometry. Unfortunately, I wasn't able to complete the preparation for this evening's class, but I'll be able to do 3 out of the 4 questions. I didn't get to finish type out the last question. Now, there's a reason why I choose to type and not just put pictures. The pictures don't display as well as how you see it on the screen here. And in order to make sure that when you're looking back, you can see clearly what's written on the screen. That's why I make the extra effort to type these questions. So it takes a lot of work to prepare these things, but once it's done for life and it's done properly. So I don't have to go back and do the work. So I will do that. It will be the May 2015 number 10. I will do it on Thursday. Well, on Wednesday when we're doing the investigation questions. Those are some easy questions that we'll be able to finish before 9. So I'll put it in before I start the investigation questions. Is that okay with you all? All right. Now, this evening for motivational thought, I just want to speak to you all about the importance of not procrastinating. Last night, while I was doing the live stream for the vectors and matrices, some of the students asked me if I would be live streaming um, next week, Wednesday night. Well, truthfully, yes, I will be live streaming next week, Wednesday night, but it will not be to teach anything. It will just be to encourage you all for about 10 minutes and pray with you all for those of you who want prayer. But I don't plan to teach beyond next week, Monday, simply because I don't wish to panic anybody. And I want you all to sit down and do the questions that I did with you now. By next week, Monday, I would have solved here 80 past paper questions from the paper 2 exam. If you're doing paper 3 as well, I would have done 4 papers, which would be the 2 possible paper 3 papers they had available. So if you work hard and do the work now, you wouldn't be rushing it down. But those who wait for the last minute to get it done, they'll realize that they'll be out of time and you will not be able to survive with this. So please sit and work now, work diligently now, every day, revise your theory, do questions, strengthen the things that you know, work on the things that you don't know. Do not wait for last minute and get a good night's sleep the night before the exam. All right. So let's begin here. I will be doing here January 2017 to January 2019, 3 questions. All right. So we'll start here with January 2017, paper 2, question 10. Part A, the diagram below not drawn to scale shows a circle with center O. The vertices H, J, K, and L of a quadrilateral lie on the circumference of the circle, and PKM is a tangent to the circle at K. The measure of angle HJL is equal to 20 degrees and JKH is equal to 50 degrees. So, part A, calculate given reasons for your answer, for each step of your answer, the measure of angle HKL. Now, in the past paper workshop earlier on, I showed you all how to deal with this. Sit down and try to work out the answer on the diagram first, all right, and then see to write out the working. So that's what I'm gonna continue to do, all right, because I want to be consistent with the methods that I teach you. Okay, so they want you here to find angle HKL. So this angle here. Now notice here that H and L, they form a chord. All right, and notice here that we have two angles in the same segment of the circle. All right, so this here is 20 degrees because angles in the same segment of the circle are equal. Okay, so this here and this here are equal. So I'm going to write that here. Yes, 20 degrees is correct, Jovan. Good to see you. So we could write here that angles in the same segment are equal. So we could say here that angle HJL is equal to angle HKL, and this is equal to 20 degrees. Let me write this 20 a little better. Okay, so that's the first part. For the second part now, angle JOK for 2 marks. Okay, good to see some students from my school tonight. So angle JOK. So we go on the diagram here and let's see what we could work out here. This is angle JOK. So the angle they want us to find is this angle. All right. Now, I want you to notice here that OJ and OK are radii. All right. And we know a radius has the same length. So what you notice here that JOK, this triangle, JOK is an isosceles triangle. And we know that base angles of an isosceles triangle are equal. So what that simply means here is that this here is 50 degrees. All right, and they want to find here angle JOK. So 50 plus 50 is 100. 180 minus 100 is 80. So therefore this is 80 degrees here. Okay, that's correct, Kevon. Okay, so I'm just going to write it out now. So base angles of an isosceles triangle are equal, and sum of the interior angles in a triangle is equal to 180 degrees. Okay, so those are your two reasons, and you'll write here that angle JOK is equal to 180 degrees minus angle OKJ plus angle OJK. All right, so this is 180 degrees minus 50 degrees plus 50 degrees. 180 minus 100. So this is 80 degrees. Okay? All right, so that's your answer there. All right, part 3. Angle JHK for 2 marks. So, again, we identify first of all JHK and we try to work it out. All right? So JHK. Now, what I want you to note this here is that the angle between the radius and the tangent is 90 degrees. Notice here that OK is a radius and MKP is a tangent. So what it's saying here basically is that this is 90 degrees here. Okay? So if this is 90 degrees, it means that this is 50 degrees. So 90 minus 50 will give me 40. So this angle here will be 40 degrees. So this is 90 here. This here is 40 degrees. All right. Now the angle between the tangent and the chord, JK is a chord. The angle between the tangent and the chord is equal to the angle in the alternate segment. Okay? So what that means here is that this here is 40 degrees. Is that clear, class? Hello, Haley. Wizkid. All right, so I'm going to write out the reason now. So angle between the radius and the tangent is 90 degrees. Okay, and that's a rule there. So angle JKP is equal to 40 degrees. So we have here that angle JKP is equal to angle JHK, which is equal to 40 degrees. And the reason here, the angle between the tangent and the chord is equal to the angle in the alternate segment. Yeah, the angle is perpendicular at the point of tangency. The point of tangency is that point of contact between the radius and the tangent. It's just a nice fancy word of saying that it's 90 degrees. Okay? Good night, Jashon. I am not a wet man though. I will send the admats notes after I'm finished with the class here, okay? After I'm finished tonight. All right, so angle. All right, so angle between. Oh, let's shine up my head here. All right, so angle between the tangent and the chord is equal to the angle in the alternate segment. Okay. All right, so that's the reason there. We're done with that. Let's move on. Part B. A ship travels from Akron A, and they call Akron A, on a bearing of 30 degrees to Bellevue B, 90 kilometers away. It travels to Compton C, which is 310 kilometers due east of Akron, which is labeled A, as shown in the diagram below. All right, so that's just the diagram and the question. Part 1. Indicate on the diagram the bearing of 30 degrees and the distances 90 kilometer and kilometers and 310 kilometers for 2 marks. So let's see what we have here. All right. So they said here that A is on a bearing of 30 degrees to Bellevue. All right. So it leaves from A, and the bearing is always measured out from where you are measuring from. And we are measuring the bearing from A. So this here is where the 30 degrees is. All right. We always measure the bearing from the north line. All right. And we always draw a straight line to connect A to B. Okay. All right. So that's the bearing. Now, the other parts what they wanted here, the bearing and the distances 90 kilometers and 310 kilometers. So the 90 kilometers away, they said that the ship travels from A to B 90 kilometers away. So this here is 90 kilometers. Okay? And now this one is a little trickier. Part C. For this C here, where the it then travels to Compton, which is C, which is 310 kilometers due east. Okay? When they say 310 kilometers due east, remember that this is north, east, west, and south. Okay? Don't forget your cardinal points. Okay? So due east would be to the right of A. So this here will be 310 kilometers. Okay? All right, so that's how many marks? 2 marks for just labeling the diagram. So even if you're a little shaky with this topic, please don't give up on any of the questions. Pick off whatever marks you could, okay? All right, so that was part A. Let's move on to part B now. Calculate to the nearest kilometer the distance between Bellevue, B, and Compton for 2 marks. All right, so what I'm going to do, I'm going to sketch a little diagram here. I like to sketch diagrams with these trick questions because sometimes all the things that they give me here tends to confuse. All right. Now, what I want you to notice from the diagram here, this is a north line. Between north and east here, this is 90 degrees, right? That's 90 degrees. So 90 minus 30 will give me 60 degrees. You're clear as to how I came up with the 60? All right. Wait, my 60 degrees disappear. All right, 60 degrees. So they want me to calculate the distance between Bellevue and Compton. So this is Bellevue and Compton. So this is the side they want us to find, okay? So in my diagram, I'm going to label here ABC, A, B, C, okay? And what they want me to find here is side A. Now remember, the capital letters are the angles and the common letters are the sides, okay? So here, angle A here is 60 degrees. We know that A to B here is, which is side C. Side C here is 90 kilometers. And we know side B here is equal to 310 kilometers. Now you could see plain out just by looking at this. You have two sides and the angle between it. So you know one time, this is cosine rule. Nicholas, could you tell me what exactly you're confused with? I could always explain again, huh? Oh, if I'm a pastor, I work as a missionary. I've been a missionary for over 8 years now. Okay. No, I'm gonna use cosine rule here. Okay? All right. I work as a missionary with a private school and I teach mathematics and teach children about God too. All right, so I like helping people. All right, so this is that. So let's get back to it now. All right, so I'm going to use cosine rule. Now they want me to find sine A. So I deliberately draw a new diagram and label it like this, so because it's very easy to write from the formula they get here. So how I got 60 degrees. All right, so let's go back to the diagram. All right, we know here that the angle between north and east here is 90 degrees. Okay? Angle between north and east here is 90 degrees. Now, if this is 90 degrees, because this is north and this will be due east, okay? 90 minus 30 will give me 60, okay? So that's how we get it. I keep lessons, but from September online, privately, okay? For now, I'm just doing this to help you all. Okay, there will be about 80 questions done over by next week Monday on this channel from all what I have in the playlist, the 2019 CSEC Math Past Paper Workshop. So just see that file there, Nisa, and you could get as much help as possible there, okay? All right, so I'm going to write the cosine rule here. This is a squared is equal to b squared plus c squared minus 2bc cos a. People, if you don't know this, it's in the formula sheet, okay? It's in the formula sheet. So if you can't remember it, just look there. That's why I keep drawing over the diagram, simply to make sure that it could be easily correlated with the formula. So you don't have to overthink. All right, so all you're doing here is substituting what we have. Okay? So we know that a squared is equal to, we know that b here is 310, so this is 310 squared. C is 90, so this is 90 squared minus 2 multiplied by 310 multiplied here by 90 cos angle A, which is 60 degrees. All right. Now, I did teach you all a trick in the workshop how to do this. You have two ways you could do this. Type all of the right hand side into your calculator, and when you've pressed equal and you get your answer, you're going to press the function y to the power of x and then press 0.5. What I'm doing here is raising the right hand side, whatever my answer. I'm taking the square root. Anytime I raise anything to the power of 0.5, it's like finding the square root. Okay? It's like taking the anything time I raise anything to the power of 0.5, I am taking the square root. So it's a nice shortcut way to not have to type over or write over anything. All right, because anytime you're doing these trig calculations, they always have a set of decimal points, and it's easy to make mistakes. So you could go from this line to this line, okay? And you will get here, and they'll ask you here to the nearest kilometer to express your answer. You see nearest kilometers. So this will be 276 kilometers, okay? Nicholas, all my live streams, I save them and leave them publicly to help you all, okay? Everybody clear with this? I'll go it over if necessary. All right, so what we have here, they ask us to find to the nearest kilometer the distance from Bellevue to Compton. From the diagram here, Bellevue to Compton is this side here. So I just redrew a diagram here. All right, so, and I just labeled. Remember, the capital letters are the vertices, these are the angles, and the common letters are the sides. Okay, the common letters are the sides. So the sides are always opposite the angles. So this is angle B, this will be side B. This is angle C, so this will be side C. This is angle A, so this will be side A. All right? And whenever one of the criteria to use the cosine rule, you have two sides and the angle between them. So one time, once you just set up your diagram and you look at it carefully, you could see that one time you could use just cosine rule to solve this. Okay? Because you have met the criteria for the cosine rule. So, and I choose to always label the new diagram that I sketched ABC, even though the diagram they gave us was ABC. Alright, but it had all these knot lines and I wanted to keep it simple. So, if you can't remember the cosine rule formula, go to the formula sheet in front of the exam. They give it to you, okay? Just take it. Just know when you have to use the cosine rule. What are the criteria when you use them, okay? It's either you have two sides and the angle between it, or you have three known sides. Okay, that's when you use cosine rule. All right. So here you have the cosine rule, and all we are doing is substituting the values of B and C and angle A into the formula. And as I told you all, you could type all of this in your calculator and press equal. And after you press equal, look for the function y to the power of x. All right, what I'm doing here basically is raising the answer to the power of 0.5. It's like typing the answer in your calculator and finding the square root of it. Anytime you raise anything to the power of 0.5, you're finding the square root. And so you could jump from this line to this line here and write the answer. And this is to the nearest kilometer. So I would have made the rounding off one time. So basically I did a piece of calculation that would sometimes take you 5-6 lines to do. I did it in 3 lines. Okay? Just by simply using the calculator properly, and I didn't make errors because as I indicated, this tends to have some problems sometimes when you have decimals. You could remember you're under pressure in an exam. It's very easy to type the wrong thing and you get this thing wrong, eh? So the less typing and copying you have to do, try to save yourself some trouble. So this is why I recommend this, okay? All right. Part 3. Calculate to the nearest angle the measure of ABC for 2 marks. All right, so ABC. So let's use back this diagram here. Angle ABC is this angle. Remember this angle here. Anytime they give you A, B, C, the letter in the middle is the angle. Okay? So that's the angle they want us to find. Now, let me show you why I'm going to use this cosine. Oh God, why I'm going to use this sine rule. All right? Notice here, I would have found the value of A. So let me write in A now. A here is 276 kilometers. Okay? So I have the 276 here. So what I have here, I have an angle here, angle A, and I have side A. Now once I have an angle and its corresponding side, and I have this side that is opposite or that is corresponding to the angle that I want to find, I will use the sine rule. Okay? So I'm going to write this out here. So I'm going to write out what I have. And I recommend that you try to write it like this because it's very easy to see what you have. A here is 276 kilometers. Angle A is equal to 60 degrees. So I have an angle here and its corresponding side. B here is 310 kilometers. And I want to find here angle B. So I have met the requirements to use the sine rule. So I'm just going to use the sine rule. And this too is in front of the formula sheet. So don't worry, just go to the formula sheet and you get it anytime you need it, okay? Just to be able to know when to use what. So we'll write here A all over sine A is equal to B all over sine B. All right? And we just substitute in here. So A here is 276 all over sine A, which is 60 degrees. B here is 310 all over sine angle B, which is what we want to find. So we're going to cross multiply here. So this is going to be 276 sine B is equal to 310 sine 60 degrees. All right? So we're going to divide here. We want sine B alone. So we divide in here by 276. Divide by 276. This cancels. And we have here sine B is equal to 310 sine 60 degrees divided by 276. So now, what I want to do here, I want to get B. Now, in order to get B, I have to find sine inverse the right-hand side. So B here is sine inverse, open brackets, 310 sine 60 degrees. Okay, y'all, I'll go it through again. Don't worry, all right? And this here is 276. Now, I choose to work it like this because, again, I don't like to copy over working. All right? All these things is very easy to make a little computation error. Doesn't mean that you don't know what you're doing, but it's very easy to make errors like that. So, what I will recommend, there's a way to type this into your calculator to not make an error. When you're typing this, put here a bracket in the numerator. Okay? Make sure and put a bracket. So you'll put a double brackets to start. All right. And then you'll put the 310 sine 60 close brackets divided by 276. All right. And then you press equal. And you'll one time you'll be able to get your answer. Now, Kevin, they told me here to the nearest, it is to the nearest degree. Okay. So you are right in your calculation, 76.58, but I got 76.6. But remember that they want you here to the nearest degree. But I'm going to put it here to 76.6 because this one's a little tricky. Okay? All right, to the nearest degree. Now let's go back to the original diagram. I want you to see something here. Okay, original diagram. This here is angle ABC. Okay? Y'all notice here that this here is an obtuse angle. It's an obtuse angle. But the angle that we calculated here in part 3 here is an acute angle. Acute angle indicating that it's less than 90 degrees. All right? So what happened is you need to be able to recall this principle. All right? Now, y'all, I don't have no other acronym for this. This is how I learn it. Please don't think anything bad of me. All school teachers cuss. Okay? What this simply means is that all the angles in the first quadrant, when we sine them, cos them, tan them, they will have a positive value. In the second quadrant here, when we sine any angle, it will be positive. In the third quadrant, tan will be positive. In the fourth quadrant, okay. All right, so I think if I say care, Ollie wouldn't remember. If I say cos, I'm sure you'll remember. All right. Anyway, so C is in the fourth quadrant here. All right. So what happens is that in the second quadrant here, sine will be positive. And seeing that in the diagram here, this is an obtuse angle. We're talking about an obtuse angle is an angle between 180 degrees, well, less than 180, but greater than 90 degrees. Okay? So we're dealing with an obtuse angle and we just use sine and the answer was positive. So we need to work out this value here. Okay? So let's see to work this out now. So from the diagram, ABC is obtuse. No, Nicholas, this live ending by 9 o'clock. My lives don't go more than 2 hours. Okay? Simply because human beings have an attention span. Okay? And good instructional design dictate that you need to teach to suit that. You can't be loading things for hours and hours. People zone out after a while. All right, so from the diagram, ABC is obtuse. All right, so I'll write here that sine 180 degrees minus theta is equal to sine theta. All right, so theta could cancel off here. So this is 180 minus theta here will be 76.6, which is the angle I calculated. So 180 minus 76.6. Jasmine, what can I say? All right, 103.4 degrees. All right, and they set to the nearest degree, so this will be 103 degrees. All right, so let's go through the working again. All right, I just want to, yes, I'm going live every day except Friday night. All right, so from the diagram that I would have drawn here, all right, I was able to identify the different parts here, and I wrote it out here. I have A, and I have the angle A. I have B, and I want to find here angle B, which is angle ABC. And remember I told you the letter in the middle will tell you which angle they want you to find. So I know here that whenever I have an angle and its corresponding side, and I have a side or an angle, and I want to find its corresponding side or angle, I always use the cosine, the sine rule. Sine rule. Okay, I'm gonna always use the sine rule. So all I did was substitute here the values, and I'm cross multiplying. I'm cross multiplying because I want to get the sine b on one side of the equation. Now this 276 here is the coefficient of sine b. So I divide both sides by sine b. The 276 will cancel off. So I write it up here that sine b is equal to 310 sine 60 all over 276. This is just the right hand side here. All right. Now, in order to get rid of this sine, I need to bring this sine on this side. But the only way to bring sine on this side, it has to be sine inverse. So I find here, so I'll find sine inverse the right hand side. Now, I told you, try not to do these calculations in parts. Learn to use the calculator properly. You're going to use two brackets, or double brackets. Make sure and use the double bracket, okay? If you just use the single bracket, sometimes it don't always work out. Okay, so just type this into your calculator and you're gonna get 76.6 degrees to one decimal place. Now what I said here in the diagram, angle B here, this is the original diagram. This is an obtuse angle. This is not an acute angle, but the angle that we calculated here is 76.6. So I'm gonna use what you all taught me today. All school teachers care. All right, and you would see that sine here is positive, not just in the first quadrant, but the second quadrant as well. And seeing that it's an obtuse angle, we will be focusing here on the second quadrant. So in order, from the diagram, we know that ABC, all right, is obtuse. So we know that sine 180 minus theta is equal to sine theta. So I just cross out here, sine theta is like dividing throughout by sine. All right, so 180 minus sine 76.6, which is theta, the angle we calculated. We are able to find the obtuse angle. Now, y'all, just for intellectual curiosity, all right, I just want you to see something. Sine 76.6, you're getting 0.97, and sine here 103, you're getting 0.97 as well. Okay, So you're seeing that you're getting the same value if you sine 76.6 and 103. Okay? So that's it for that part. Let's go to part 4 here now. Determine the bearing of Compton from C from Bellevue for 3 marks. Alright, so let's go up to this diagram. So they want here the bearing of C from B. So the bearing of C from B. So we are measuring where we bearing is always measured at where we are measuring from. Okay? So the bearing of C from B, and it's measured from north. So the angle we want to find here, this is the bearing. Okay? This is the bearing. Now I'm going to work this out on the diagram first before I do it just like how I do all the other calculations. Now you see in this north line here and this north line here, these are two parallel lines. And what you have here are co-interior angles. So if this is 30 degrees, it means here that co-interior angles are supplementary. So this angle here is 150 degrees because 180 minus 30 will give me 150 degrees. And we found here that this angle is 103 degrees. Remember, this is angle B that we calculated here. All right, this is angle B, which would be angle B. Okay, this is 103 degrees. So this is 103, this is 150. So when I add up these two angles and I subtract it from 360 degrees, I'm able to find this angle, which is the bearing of C from B. So I'm just going to write that out there. So bearing of C from B is equal to 360 degrees minus angle ABN plus angle ABC. All right. So we have 360 degrees minus 150 degrees plus 103 degrees. So this is 360 degrees minus 253 degrees. So this is, excuse me, 107 degrees. Okay? So here we have 107 degrees. So therefore the bearing of C from B is 107 degrees. So I'm just going to write here 107 degrees. Okay? So that's the end of the question there. All right, so we are finished with January 2017. All right, so let's go now to May 2016. All right, May 2016, paper 2, question 10. Part A, the diagram below not drawn to scale shows a circle, center O. EH and EF are tangents to the circle. FOG and GOH are straight lines. The measure of angle FEH is equal to 44 degrees. All right, so they want us here now to find angle EHF for 2 marks. So let's go to the diagram here. Let's identify angle EHF. EHF. So the angle they want us to find here is this angle. All right? Kevin, I have no prophetic gift that I could prophesy what coming for 2019. All right? I have no gift of clairvoyance in any way. So I will tell you, just study everything, boy. Study everything and just practice your past papers. Good preparation. And just focus and give good preparation. That's all I could tell you. All right? Sorry I can't give you anything more because I honestly don't know. All right. Now, this is angle EFH or FHE, and they want us to find this. Now, what I want you to realize is that you have two equal tangents can be drawn from any external point like E. Okay, so when you draw from an external point here, these tangents are equal. So what this means, if these tangents are equal, you mean the sides of this triangle FHE are equal. All right. So if these are equal, what you have here, this is an isosceles triangle, and we know that base angles of an isosceles triangle are equal. Okay, so what that means here is I could say 180 minus 44 and then divided by 2, and I'm going to get 68 degrees here and 68 degrees here. Okay? All right. So that's what I'm going to write out here. So two equal tangents can be drawn from an external point. All right, so triangle EFH is isosceles, ISOS. Okay, so we know here that base angles of an isosceles triangle are equal. So we could write here that angle EHF is equal to 180 degrees minus 44 degrees divided by 2, and I'm getting here 68 degrees. All right? How I know it's an isosceles triangle? So let's go back to the diagram. There's a theorem that says only two equal tangents can be drawn from an external point to a circle. Okay? You have to know your circle theorems to be able to do this, but that's what the theorem says. Only two equal tangents can be drawn from an external point to a circle. Okay? So therefore, EH and EF are equal in length. So what you have here, triangle EFH is an isosceles triangle. And we know that base angles of an isosceles triangle are equal. So 180 minus 44 divided by 2, and I'm getting the 68. Okay? All right, so part A2 here. Angle FGH for 2 marks. All right, so angle FGH, let's find that in the diagram first. So FGH, all right? So let's write that here. This angle here. Now, what I want you to see here, you see in FH here? FH is a chord. And you see in FE, this is a tangent. So the angle between the tangent and the chord is equal to the angle in the alternate segment. You all seen that? I'll say it again. FH is a chord, FE is a tangent. The angle between the tangent and the chord is equal to the angle in the alternate segment. So this is 68 degrees. Okay? Excuse me, yeah? All right. So I'm going to write this here now. So angle FGH is equal to angle EFH is equal to 68 degrees. So we have here angle between the tangent and the chord is equal to angle in the alternate segment. Okay? And that's all. All right, part 3. Angle JHE. Angle JHE. So let's go to the diagram. Identify angle JHE. JHE. Now I want you to see here that OH is a radius. Remember, O is the center of the circle. H is the point of tangent C. All right? That point here that meets the radius. So what you have happening, there's a theorem that says the angle between the tangent and the radius is 90 degrees. Okay? Or they are perpendicular. So therefore, this is 90 degrees here. All right? So just going to write this in here with the reason. So angle JHE is equal to 90 degrees. And this here is the angle between the radius and the tangent. It's equal to 90 degrees. All right, and that's it there. So let's go to the fourth part now. Angle JGH. Go to the diagram. Angle JGH. Nicholas, it takes time to learn all these theorems, all right? It takes time. All right, what I'm doing here just merely shows you how to apply them. You have to take your time and learn the theorems. That's why you learn this whole math syllabus. It's really testing you 5 years of mathematics, academic years. Okay? So, angle JGH. JGH. Now notice here that FOG, all right, is a diameter. Okay? And we know here that and JOH here is also a diameter as well. All right? And what I want you to see here, put this in a different color here. They want you to find JGH. We know that there's a theorem here. No, Nicholas, it's not 44. JGH, the whole angle here that I indicated here, this is 90 degrees because JOH here is a diameter, and you will notice that this diameter forms a semicircle. So the angle in a semicircle is 90 degrees. This is one of the theorems as well. All right, this is the second theorem. Angle in a semicircle is 90 degrees. All right. So once you know your theory, you could pick it off really easy. It's easy 2 marks. If you don't know your theorems, trouble. Okay, so angle JGH is equal to 90 degrees. So the angle of a semicircle is 90 degrees. And that's it for that part. Let's go down here to part B now. Part B, the diagram below not drawn to scale shows 2 ships, R and S, at anchor on a lake of calm water. FT is a vertical tower. FSR is a straight line. RS is equal to 150 meters. The angles of elevation of T, the top of the tower, from R and S are 22 degrees and 40 degrees respectively. F is the foot of the tower. All right, so let's go to part 1 here. Calculate, given your answer to 1 decimal place where appropriate. Part 1, the measure of angle RTS. All right, so let's go to the diagram here and let's figure out angle RTS. All right, let's see where RTS is to start with. RTS is this angle here. Okay? RTS, the letter in the middle. Okay? So that's the angle they want us to find. Now we know here that the angle of a straight line is 180 degrees. So 180 minus 40. Yes, elevation means looking up. Okay? So you're standing at S here, you're looking up at T, that's the angle of elevation. You're standing at R here, looking up at T, that is 22 degrees. Okay? Now, the angle of a straight line, they told us here that FSR is a straight line, it's on level ground. Okay? So we know that the angle of a straight line is 180 degrees, and 180 minus 40 degrees is 140 degrees. And we know that the sum of the interior angles in a triangle is 180 degrees. So 180 minus 140 plus 22 here. So that's 180 minus 162, and you should get 18 degrees. Okay? All right, so let me just write that out there. So angle RTS is equal to 180 degrees minus 140 plus 22. 180 degrees minus 162 degrees. This here is 18 degrees. Okay? Okay, part 2 now. The length of ST. All right, so let's go to the diagram here. ST is, let me just get this hand tool here. ST is from S to T, this line here. Okay, so what I'm going to do, you see how they give you this R and S and T and all this thing? It's very easy to confuse you. So I'm going to sketch a diagram, label all the information that I have, and we will use that information here to easily determine what we're using to do this calculation. So that is when I recommend to use the to sketching your own diagram. All right, so y'all I really can't draw to save a life, you know. All right, that looks better. So this is A, B, and C. Now remember the capital letters that represent the vertices, which are the angles, and the sides that are opposite the capital letters or the angles will be common, and these will represent the sides. So this will be side A, all right? This here will be side C, and this here will be side B, all right? Now, notice here from the diagram here, they wanted ST. So ST in our diagram will be B. So that's what they want you to find. Okay, so I'll just take off A for now. I don't want you to confuse you by writing too many things. And we know here that C here is 150 meters. And let's write in the angles we have here. This here is 140 degrees. This here is 22 degrees. And this here is 18 degrees. All right? So let's write out the information we have. They want us here to find B. All right, and we have here angle B. Angle B here is 22 degrees. And we have here side C. Side C is 150 meters. Angle C here is 18 degrees. So we're using sine rule. That's correct, Tristan. We're using sine rule because we have here an angle. So we have an angle and its corresponding side, and we have the angle opposite the side we want to find, or corresponding to the side we want to find. That's why Whenever we have a case like this, we use sine rule. So I'm going to write here this is going to be B all on sine B is equal to C all on sine C. All right, and I'm going to substitute in and solve for B. So B here all over sine 22 degrees is equal to C, which is 150 all over sine 18 degrees. Okay? And I'm going to cross multiply now because remember I'm trying to solve for B. So this is going to become B sine 18 degrees is equal to 150 sine 22 degrees. Divide by sine 18 degrees, divide by sine 18 degrees. This cancels. So therefore, you just plug in this into your calculator here, all right? And you just work this out, okay? Could use a bracket if necessary, all right? And divide, and you'll be fine. I'll put the bracket in a different ink here so that you will not get confused in any way. All right, so when you do that here, remember they ask you to do the calculation to one decimal place. So this is 181.8 meters. All right, so therefore, ST is equal to 181.8 meters. All right, well done, everybody. All right. All right, so, all right, I'm not sure why this disappear like that, but anyway. Part 3. The height of the tower FT for 3 marks. Okay, so again, let's sketch a little diagram here. All right, this is F, this is T, and they gave us here that this is a right angle, and this is S. All right, and I'm showing you where I'm getting this information. F, T, right angle, this is S, and this here is 40 degrees. So I'm going to write this into the information that I have. This is 40 degrees here, and they want me to find FT. All right, so once you need to know when you're using sine rule and cosine rule, and you need to know when you're using SOHCAHTOA. Sine rule and cosine rule is used for triangles that are not right angle triangles. SOHCAHTOA, you're using that for only right angles. SOHCAHTOA and Pythagoras theorem are only applicable to right angles. We have a right angle here, so I'm going to use SOHCAHTOA. I was shocked that they gave you this thing for 3 marks, to be honest with you. We know here, all right, that TS is, which is what we, ST, which is what we just found here to be 181.8 meters. So 181.8 meters, okay? And this here is my hypotenuse because it's the longest side of the triangle and it's also opposite the right angle. All right, and they want me to find FT. FT is opposite the angle. Now all I write here, SOHCAHTOA, and ask myself which one of these trig ratios here has H and O in it. Which one? Sine. You see in the O and the H here? O and H here. H, O. So all you really need to know for SOHCAHTOA is literally this. You don't need to memorize the trig functions really. Just know SOHCAHTOA, know how to draw a right angle triangle, learn how to identify your adjacent and opposites, identify what they gave you and what they want you to find, and you could easily just identify this. This is how I teach this. I teach the children how to think to solve this rather than they just regurgitating and they don't know how to think for themselves. Because at the end of the day, that's what math's supposed to teach you, how to think. All right, so we know that the sine rule, sine we're using here. So sine theta is equal to opposite over hypotenuse. And you could figure that out here. O over H. All right, same way like adjacent over hypotenuse, same way like opposite over adjacent. It's really easy to work out, okay? So we're using sine, it's over H, so it's opposite over hypotenuse. So this is sine theta here is 40 degrees. My opposite here is what I want to find. And my opposite here is FT. Okay? And my hypotenuse here is 181.8. So I'm going to put this over 1 and cross multiply here. So 1 by FT is FT. And this is 181.8 multiplied by sine 40 degrees. So this is FT and not FF. This is a little error on my part. FT. So FT here, when you multiply this out to one decimal place, you're getting how much? I'm getting 160.9 meters. Now a little caution here when you're doing these questions. Whatever you do, make sure your calculator is in degrees mode. If it happens to end up in radians mode, you'll be in real problems. You will not get the right answer for all your trig calculations. So please make sure that your calculator is in degrees mode. All right, so this again was a really easy problem. I was shocked that they really give you it for 3 marks, but I'll just run it through again. They wanted you to find here FT, okay? And so they wanted you, yes, you could use any angle to find the missing side, but use the ones they give you, okay? No, Janelle, they said to do your calculation to one decimal place, so you don't need to round it off, right? Not that you're wrong, eh? You just followed whatever the instruction they gave you. You use that, okay? All right, so they want you here to find FT. We found here ST, so we have our hypotenuse, we have an angle. All right, and this is a right angle triangle, so you could use SOHCAHTOA. So we know this is the hypotenuse, so we identified it as the hypotenuse. And FT here is the opposite. It is opposite the angle 40 degrees. If it was FS here on this side, it will be adjacent, next to the angle. Here it is opposite the angle. So all I do here, I write SOHCAHTOA, and I ask myself, which trig ratio has O and H in it? It's only sine. So I write here, sine theta is equal to opposite over hypotenuse. And I'm going to substitute here. All right, I'm going to substitute here. So theta is 40, hypotenuse is 181, cross multiply. So FT is equal to 181 multiplied here by sine 40 degrees. FT is equal to 116.9 meters. And we are finished with this question. So let's do the last one for the night. And I promise you all, by God's grace, Wednesday, first things up before we do the investigation question, we'll do the May 2015 paper, okay? Paper 2, question 10. So we're going here to January 2016 now. All right, so January 2016. Part A. The figure below, not drawn to scale, shows a circle with center O. The radius of the circle is 21 centimeters and angle HOK is equal to 40 degrees. All right, so this is our diagram here. It only looks complicated, but I'll show you all how easy this is, okay? Part 1. Determine the area of the minor sector. Doesn't matter, they tell you sector, okay? Whether it's minor, major, there's one formula for it. All right, angle of a sector. And listen, if you even forget this formula, I believe it's in the formula sheet too. Just double check, but I believe it's there. Angle of a sector is equal to theta over 360 degrees multiplied by pi r squared. Now, if you even examine this formula, just for intellectual curiosity, what they do here is you're finding the fraction of the area. Remember, the area of a circle is pi r squared. So whatever the angle of the sector is, you just find in a fraction of an area. Okay? So that's to find this area of the sector. So they want you here. The radius here is 21. So I could write here that r, this is equal to r. Theta here is 40 degrees. So, and they tell you here to use pi to be 22/7. So you just use that. Okay? So I'm going to write here. This is going to be 40 all over 40 degrees all over 360 degrees. Multiplied by pi here is 22/7 multiplied by the radius. The radius here is 21 squared. Okay? So when I multiply this out on my calculator, I'm getting here 154 centimeters squared. Okay, don't forget your units. Units are important. So area of a sector is given by the formula theta over 360 multiplied by pi r squared. Theta, which is the angle they gave us here, is 40 degrees. The radius is 21 centimeters. All right, and they told me here to use pi to be 22/7, so I just substitute in, multiply out on my calculator, and I'm getting here 154 centimeters squared. All right, part 2 here. The area of the triangle HOK. So in the diagram here, the area of the triangle is HOK here. Now, I want you to realize that OK is a radius and OH is also a radius. So if the radius here is 21 centimeters, it means that this side here is 21 centimeters. You all seen that? This side here is 21 centimeters as well. Okay? Now, anytime you have an angle between two sides here in any triangle, you could use here a special formula, all right, for area of a triangle. Area is equal to a half AB sine C. So I'm going to use that here. All right, so area of a triangle. This too is in the formula sheet. It's in the front of the exam paper, okay? Is equal to a half AB sine C. And obviously you need to know how to use this formula. All right? As I said, from the diagram here, A and B are the two sides here. So one side will be A, one side will be B, and theta here is the 40 degrees. Okay? So this is a half. A here will be 21, B will be 21, and this is sine angle 40 degrees. Multiplying this out on my calculator to 2 decimal places. Now, they didn't tell me how many decimal places to use, so if you choose to use 1, that's okay. I'm just using 2 here, 141.73 centimeters squared. Okay, so that's the area of the triangle there. Please learn how to use this formula if ever you have some kind of complicated calculation to do, and it comes in useful either here, sometimes in measurements. So something useful to know. Part 3, the area of the shaded segment. So in the diagram here, we found here the area of the sector, which would be this whole, think about it like a pizza. So this is a pizza slice. All right, and just say like you don't like the ends here and you decided to cut it off and just make a triangle. So this end that you want to throw away, the shaded region here, that area, that shaded region you want to find. So what you'll do is take the area of the sector and subtract the area of the triangle, and you'll get the area of the shaded region. Yes, you're going to minus the 2. So I'm just going to write that here. So you realize this was some real easy marks, right? If you know what to do with it. So the area of the shaded region is equal to the area of the sector minus the area of the triangle. So this is equal to the area of the sector is 154 centimeters squared minus the area of the triangle is 141.73 centimeters squared. So I'm getting here 12.27 centimeters squared. If some of you all rounded off to one decimal place, 12.3 is fine as well. That's your answer. So let's get on to part B. Okay? Part B. The diagram below, not drawn to scale, shows a circle with center O. TAE is a tangent to the circle at point A, and angle AOD is equal to 72 degrees. All right, so they want you here now to find here, calculate giving the reason for each step of your answer, the measure of angle ADC for 2 marks. So let's go to the diagram here. Have a nice big diagram here. And angle ADC. So let's locate ADC. ADC. All right. So one time you could see here that ACD or ADC, you could see that this is a triangle, right? And notice that AOC is a diameter. So you have a triangle with a diameter here. So this is a semicircle. You can notice here, watch. This is a semicircle. And we know that the angle in a semicircle is 90 degrees. That's one of your theorems. Okay, so this here is 90 degrees. All right, so angle ADC is equal to 90 degrees. So we could easily write that out. Yeah. So angle ADC is equal to 90 degrees. And the reason here is the angle in a semicircle is 90 degrees. Yes, that's correct, Kavon. All right. So let's go on to part 2 here. Angle ACD. All right. So let's go to the diagram. Let's see what we have here. ACD. Okay. ACD. So this is the angle that they want us to find. This angle here. Now notice here that A and D, this is where this angle starts to form from. Okay. And notice that A and D is also where this angle here at the center is used to start from. Now we know that the angle at the center of the circle is twice the angle at the circumference standing on the same arc or chord. This is the same arc, AD, and the same chord is AD. So both of these are these two angles are standing on the same arc or chord. So this is 72. This will be twice, the 72 is twice the size of angle ACD. So 72 divided by 2 is 36. So this is 36 degrees here. All right, and I'm going to write out the working. So I'm going to write here that angle ACD is equal to a half of angle AOD. This is equal to a half of 72 degrees. So this is equal to 36 degrees. And we know here that the angle at the center of the circle is twice the size of the angle All right, the angle at the center of the circle is twice the size of the angle standing on the same arc or chord. Angle at the circumference, twice the size of the angle at the circumference. All right. Now, usually I write this thing in a shorthand. I should not have gone that long route, but angle at center is equal to 2 times angle at circumference. I tend to prefer the shorthand. Okay? All right. So that's it for that there. Angle at the center of the circle is twice the angle at the circumference standing on the same arc or chord. Okay? Part 3, angle CAD. All right. So go to the diagram. Angle CAD. So you're talking about this angle here. Now, this angle here. Now, to be honest with you, there are 2 ways you could work this one easily just by looking at the diagram. You know that this is OA and OD. These are radii. So base angles of an isosceles triangle will give you this answer here to be 54 degrees. All right, that's one way of doing it, but there's an easier way of doing it. If you know this is 90 degrees and this is 36 degrees, 90 plus the 36 is 126. We know that the sum of the interior angles in a triangle is 180. 180 minus 126 will give me 54 degrees. Okay? So, any one you choose. The second method there is easier though. So, angle CAD is equal to 180 degrees minus 90 degrees plus 36 degrees. This is equal to 180 degrees minus 126 degrees. This here is equal to 54 degrees. All right, and this the sum of the interior angles in a triangle is equal to 180 degrees. All right, that's the reason. All right, but as I said, you could also use base angles of the isosceles triangle. It will also give you the correct answer. All right, last part for the night. Angle OEA. So let's find that. Angle OEA. So this is the angle they want us to find here. All right, this angle here. All right, so I want you to notice here that the angle OA is a radius. Okay? Nicholas is usually 9 o'clock, but remember, you probably weren't here when I started the class. I wasn't able to type out the last question. Okay? So usually I do 4 questions in a class, but work got the better of me today. So I will do it later on this week on Wednesday. So that's why we're gonna end earlier, okay? All right, so notice here that OA is a radius and TAE is a tangent. We know that the angle between the radius and the tangent is 90 degrees. Maybe I should use another color here. See, now we have so much red. All right, so this here is 90 degrees. Now, if we know that this is 90 degrees and the angle at this here, AOD, this is 72 degrees. We know here that the total interior angles in a triangle is 180. So 90 plus 70 is 162. 180 minus 162 will give me 18 degrees. So this here is 18 degrees. Okay? I'll say it again. TAE is a tangent and the angle OA is a radius. Anything from the center of the circle to the circumference is a radius. So the angle formed between the radius and the tangent at the point of contact is always 90 degrees. This is one of the theorems. So if this is 90 degrees and this here is 72 degrees, 90 plus 72 is 162, and the sum of the interior angles in a triangle is 180 degrees. 180 minus 162 will give me 18 degrees. So I am gonna do that out here and we're done for the evening. All right, so I'll write here that angle OEA is equal to 180 degrees minus angle OAE plus angle AOD. All right, and we know here that the angle OAE is equal to 90 degrees, and the reason here, the angle between the radius and the tangent is equal to 90 degrees. All right, so we could write here that angle OEA is equal to 180 degrees, and we're just substituting here. This is a minus sign. Minus angle OAE is 90 degrees. Angle AOD is 72 degrees. So this is 180 degrees minus 162 degrees. So this here is 18 degrees. All right, so y'all, we made it to the end of the class tonight. Tomorrow I will be doing relations, functions, and graphs. This is section 2 we're doing, okay? And on Wednesday, I'm gonna do the May 2015 number 10, the number 10 trigonometry and geometry question, and then we will do the investigation questions. Please come out to that class. The May 2016 investigation questions are really tricky but lovely question. I want to show you all a new technique. Tristan, we are doing statistics on Sunday morning from 10 to 12. Sunday have 3 classes, 10 to 12, 2 to 4, and 7 to 9. I'm sorry I didn't get a chance to post to copy and paste everything onto the slide here, and I don't want to mess up what I'm doing here, but I do have a schedule in place. The students at my school would have had it, but I could tell you what's happening tomorrow night: relations, functions, and graphs. On Wednesday we're doing the investigation questions. On Thursday we're doing measurements. On Saturday night, remember I have no classes on Friday night. On Saturday night at 7, all the classes are 7 unless it's stated otherwise. On Saturday night we're doing we're doing trigonometry and transformations. Sunday morning we're doing statistics. Vectors and matrices was last night. Just check my YouTube channel. You will see that it's there. Okay? That's okay, Kevin. If you have to go to church, you go to church and pray, boy. Alright? Go to church and pray, and you'll get a copy of it after. Alright? That's not a problem. Alright? So, that's it for the evening. Alright? I'll see you all tomorrow, by God's grace. Alright? Take care, and have a good evening. Study well. Make sure and sleep. Y'all, please make sure and sleep. Don't do this madness of not sleeping. You will not be able to remember. You need to take care of your health at this time, okay? All right. All of you who have to go to church, that's okay. All right. You could always join, catch it up afterwards. All right. Take care. Bye bye.